Hello friends, this is another week to continue the class. Looking at this bus bar, we got to this point and then we calculated our I1. Today we are going to continue as we calculate our I2. For I2, we are saying that I2 is equal to V2, which is telling us that the voltage that is coming from this bus bar 2 times its main admittance plus Y12, which is also the voltage, which is the admittance from bus bar 1 to bus bar 2. Then you multiply by subtracting V1, the voltage from bus bar 1 from the bus bar 2, and then you get this equation. From here we can calculate I3 to be in this form and then I4 to be this form. At this point, when we summarize what we have just written, just by arranging them in the form that we see, then we can see that from here, rearranging the equation and rewriting them into matrix form, we have I1, I2, I3, which is equal to the admittances we see over here times the voltages, because multiplying this by that, when you do the expansion from the previous point that we saw here, then we are going to get this. So as engineers, we are saying that there are laws governing whatever thing we are doing. So when you see y10 plus y12 plus y13, then it means that we are talking about all the admittances connected to bus bar 1, and that is what we call the y11. So when you see negative of y12, then we are talking of y12, meaning that the negative of y12 is what we are going to put in place of this. Then negative of the y13 is what we're going to put here. When the bus bar 1 was never connected to bus bar 4, so therefore we have what we call y14 to be equal to 0 over here. So for your assignment or for an example, you are going to obtain the admittance matrix from the 3 bus bar system in the figure below. So we have bus bar 1, bus bar 2, and bus bar 3. So the solution is that we have y11 to be equal to this, which is the sum of all admittances connected to bus bar 1, which are these values. We add them by punching the calculator. We get 3.9 minus G7. So y12 is equal to the negative of y12, and that is by negating the y12 value, and you get what you see there. So to continue, we are saying that when you find the rest of the values, this is what you're going to get, or for the admittances. So in a simple term, you can be given the following line impedances of a 3-bus bar system, and it's the same like the drawings we just saw. So you have these values, then you're going to solve them by, because this is the line or the bus bar. So we have from bus bar 1 to bus bar 2, we have from bus bar 1 to bus bar 3, and then from 2 to 3. So we have y1 2, then we know how to calculate. So it's just 1 over the r plus the x. So as we know how to calculate already from the previous class, these are the values we're going to get. Then when you get those values, you can now form a matrix from that. So after you've gotten the values, you know from the previous class that we have what we call the matrix, and then we are supposed to follow the matrix rules. So I think we'll end here for today, but note that the current or the nodal equation for a system comprising an n number of buses can be expressed in the matrix form as I to be equal to y times the v, where we have the voltages at the nodes as the v, we have the current injected into the nodes or the buses as the I, and we have the y as the admittances. So looking at this, we won't take the ith level or the ith bars, then we are going to get the summation of some y, which is the admittance, times some v at the ith level of a certain constant k, where k is equal to 1. So whilst k is changing, I will also be changing. So we shall end here, and we shall continue next time. Thank you for this weekend lecture. I wish you all the best. Stay safe whilst we go through this COVID season. Thank you.